Hi, welcome to How Does Our Gut Affect Our Brain? My name is Barbara Solomon. I'm a board certified nutrition specialist and certified functional medicine practitioner. Before we get started, I need to go over a disclaimer. The following is for information only and not intended to be used to diagnose, treat, cure, or prevent any illness. That should not be considered medical advice and is not a substitute for care by a licensed. As Hippocrates said, all disease begins in the gut. Our biome, we need to talk about our biome. Bacteria in our gut is not a bad thing. As a matter of fact, we have over 30 to 50 trillion cells in our body, but only 1 in 10 of them is actually us. The rest are bacteria, fungi, viruses, and other microorganisms, including your microflora. Our bodies contain anywhere from 2 to 3 pounds of this stuff, so it's pretty prolific and it plays a key role in our health. So what does our bacteria do for us? It keeps our digestion functioning correctly. It supports the immune system. It helps make vitamins and neurotransmitters. It regulates our minerals. It influences our genetic expression. It stimulates the production of Sig-A, which is our immunity, as well as our T killer cells, plus a whole lot more. We're just at the infancy of learning what gut bacteria actually does for our health. Now, how does the gut affect our health? Well, over 50% of our immune system resides in our gut, and for good health, there needs to be a ratio of 80% of good bacteria to 20% bad bacteria. And if that reverse happens, it's something called dysbiosis. So if people talk about that, now you know what that means. Now, gut bacteria has been linked to so many chronic diseases. All you have to do is spend hours on PubMed, and you'll just be completely exhausted by it. But it's been found to be influences diabetes, obesity, autism, Parkinson's, macular degeneration, depression, anxiety, OCD, so much more. So how does gut function specifically affect our brain? And we're going to talk about some key things here. Let's start with diet. It's not only what you eat, but how you eat that can affect brain function. Because if we don't have the right nutrients, we can't manufacture or utilize our neurotransmitters. A study showed that cultures with traditional healthy diet patterns have a 25 to 30% lower rate of depression. That's huge. I've also seen studies that point to elevated risk of depression in those with insulin resistance. So very, very important to have good, stable blood sugar throughout the day. Have a diet that's balanced with protein, carbohydrates, and fats, and eat frequently so that you don't have blood sugar fluctuations. The second bullet talks about inflammation at the gut, and this is really important because there's toxins such as lipopolysaccharides that can affect blood sugar as well as decrease the availability of things like tryptophan and zinc required for serotonin production. Really, really important. The third bullet is our overload of our antioxidant system that can influence neurotransmitter status, and that's definitely true because as we're trying to make up for deficiencies in our antioxidant status, we end up using resources that we would have used for neurotransmitter production and utilization. Number 4 talks about stress, and stress has been shown to directly affect hippocampus tissue. Fortunately, this can be changed. Stress can also really affect the composition of our microbiome. Stress has so many effects on the body, and we have a whole other webinar just on stress and blood sugar alone. Number 5, not enough of the good bacteria. We specifically need Bifidobacter and Lactobacillus. And I'm going to just point to a few outcomes of a few studies. Researchers engineered gut bacteria that were administered to lab rats. The later then showed changes in behavior. Anxious mice were actually turning bold, while shy mice were made more sociable. So just by the introduction of having good bacteria actually was able to change the emotional state in these rats. Now, additional studies on people also show that individuals consuming specific strains of bacteria changed their brain activity and reduced their anxiety. There was a group of 22 men who took a pill laden with bacteria for 4 weeks. They reported less daily stress. Their memory had grown a lot sharper. So this is really, really good stuff. Bacteria, another study showed that bacteria obtained from depressed people, they were inoculated in rats, and the rats actually became depressed. So it really shows the influence that these bacteria have on our expression. How did this happen? Well, it appears that the gut bacteria are able to synthesize chemicals that are used by the brain cells for communication purposes. For instance, Bacillus is known to make dopamine and Enterococcus to make serotonin. Brain inflammation. Now, this can affect neurotransmitters and growth factors such as brain-derived neurotrophic factor, or BDNF. In addition, substances such as short-chain fatty acids can pass through the blood-brain barrier, and they can inhibit neurotransmitter uptake. And finally, the vagus nerve. And that can lead to issues with slowing down digestion, so you don't get the nutrients you need. This poor digestion can create toxins that compromise the production and utilization of our neurotransmitters. In addition, inflammation of the vagus nerve can affect the brain and cause inflammation occurring at the brain. This vagus nerve connects our gut to our brain, and actually up to 95% is in the direction of the gut to brain, not brain to gut, as we would have thought. Let's look at Mary. We've met her before. Mary's a 50-year-old female. She has a healthy diet. She is overall healthy. She's tired. She's gained some weight. But the things the things that really are bothering her is her anxiety and her depression. What do we do on Mary? We run a functional blood chemistry on her, and we find out these various things. She has some gut issues. She has some blood sugar issues. She has nutrient deficiency. She has possible infection, inflammation, methylation, and thyroid issues. Many of these, and actually all of these, can contribute to brain chemistry dysfunction. Again, we look to see, well, what's going on in her gut? Very important to look at her gut. We found out she has an H. pylori infection. She has an overgrowth of opportunistic bacteria. She's got a parasite, and actually she had Giardia. She has an anti-gliadin antibody, so gluten is also affecting her and causing inflammation in the gut, probably vagus nerve and brain as well. High calprotectin, which means she has a lot of inflammation in her gut, and a low Sig-A, which means her immune system in her gut is not stepping up to the plate. We also ran organic acids because we love to see what happens at neurotransmitters, and we found that there's lots of things still going on, but in addition to the infections, we find that she has a problem with methylation. She has very low neurotransmitters and low B vitamins, and issues with glutathione and methylation, which could definitely be attributed to antioxidant suppression. So lots of things. She has lots of SNPs if we were to look down that, because she got her genes tested, and we find that she has neurotransmitter issues, COMT, MAO. She's got methylation. She has problems utilizing fat. She has problems with all kinds of gut things. So just some data to show you the correlation between gut and brain, gut and brain, gut and brain. And we are just at the infancy of this. This biome is just exploding right now. What do we do for someone like this? We do the 4R protocol, especially getting rid of infection and source of inflammation. So we're going to remove foods that are inflammatory. We're going to get rid of this Giardia infection, the H. pylori infection, the opportunistic bacteria that are growing out of control. We're going to help modify our diet to get blood sugar under control, to support the adrenal glands and reduce inflammation. We're going to provide her some basic support, a multivitamin, some essential fatty acids, some vitamin A to help the Sig barrier, vitamin D to help with the immune system. Really important. And we're going to eventually then look for systemic issues that steal methylation, because we want to make sure we have enough methylation to support the production and utilization of our neurotransmitters. Actually, absolutely key. That was just a really quick overview. I just kind of wanted to give you a flavor of how the gut might be influencing the brain. If you want to learn more, check out our website. We do have articles on our common conditions about brain function. We also, in our new book, Limiting the Pain of Elimination Diet, talk about this connection in significance. We have a whole section on neurotransmitters, and we have a whole section on gut, so it's really important. This is more than just about diet. This book is about a functional medicine approach to diet and health-related issues. Thank you very much. Have a great day.